Hey everyone, welcome back to the networking series. Today we're diving into the world of network protocols. Protocols are the rules that make networking possible, and understanding them is crucial for anyone who works with networks. In this video, we'll focus on two of the most important protocols, TCP and UDP, but we'll also touch on a few others that play a key role in how data moves across networks. Let's get started. First, what exactly is a network protocol? Think of protocols as the languages that devices use to communicate with each other. Just like people need a common language to understand each other, devices on a network need protocols to ensure they're speaking the same language and following the same rules. Protocols define how data is formatted, transmitted, and received. They ensure the data being sent from one device can be understood by the receiving device, regardless of what kind of device it is or what software it's running. Now, let's start with the Transmission Control Protocol, or TCP. TCP is one of the most commonly used protocols on the entire internet, and it's all about reliability. When you send data using TCP, it makes sure that all the data arrives at its destination in the correct order and without any errors. Think of TCP as a courier service that tracks every package and guarantees delivery. If a package gets lost, TCP will resend it. If the packet arrives out of order, TCP will reorder them correctly before delivering them to the recipient. This makes TCP great for applications where data integrity is crucial, like web browsing, file transfers, and emails. But all that reliability comes at a cost because TCP has to establish a connection and track every packet of data. It adds some overhead, making it a bit slower compared to other protocols. That's where User Datagram Protocol, or UDP, comes into play. UDP is like sending a postcard. There's no guarantee that it will arrive, but it's faster because there's no need for acknowledgement or error checking. UDP doesn't bother with establishing a connection or ensuring that packets arrive in the correct order. It just sends the data and moves on. This makes UDP ideal for applications where speed is more important than reliability, such as online gaming, live streaming, and voice over IP calls. In these cases, it's better to have data arrive quickly, even if a few packets get lost along the way. So, to sum up the difference, TCP is all about reliability and accuracy, while UDP is focused on speed and efficiency. Both have their strengths and are used in different scenarios, depending on the needs of the application. Now, let's take a look at a few other important protocols that you're likely to encounter in networking. First up is HTTP, or Hypertext Transfer Protocol. HTTP is the foundation of the web, and it's used for transferring web pages and other resources between your browser and a web server. Whenever you visit a website, your browser is using HTTP to request and receive the content from that web page. Next is FTP, or File Transfer Protocol. FTP is used for transferring files between computers on a network. It's commonly used for uploading or downloading files to and from a server. While FTP is still widely used, it's important to note that it's not the most secure protocol because it doesn't encrypt the data being transferred. For secure file transfers, you'll want to use SFTP, or Secure File Transfer Protocol. SFTP adds a layer of security by encrypting the data during the transmission, which helps protect sensitive information from being intercepted. Another crucial protocol is SMTP, or Simple Mail Transfer Protocol. SMTP is used for sending emails. When you click send on that email, your client uses the SMTP protocol to deliver the messages to the recipient's mail server. If you're dealing with email servers or troubleshooting email delivery issues, you'll definitely come across SMTP. Let's not forget about DNS, or Domain Name System. DNS is like the phone book of the internet. It translates human-readable domain names like www.example.com into an IP address that computers use to identify each other on the network. Without DNS, we'd have to remember the IP address of every single website that you ever want to visit. Definitely not ideal. Another essential protocol is DHCP, or Dynamic Host Configuration Protocol. DHCP automatically assigns IP addresses to devices on a network. When you connect a new device, DHCP takes care of giving it an IP address, the correct subnet mask, gateway information, and its DNS settings. This eliminates the need to manually configure every device, which can save you a lot of time and reduce errors. Let's discuss ICMP, or Internet Control Message Protocol. ICMP is used by network devices to send error messages and operational information, such as when a requested service is not available or a router cannot be reached. When you use the ping command to test connectivity from one device to another, you're using ICMP. One more important protocol to mention is SSH, or Secure Shell. SSH is used for securely accessing remote devices over a network. It encrypts the connection, ensuring that data transmitted during the session cannot be intercepted. This makes SSH ideal for remote administration of servers and network devices. So we have covered a lot of ground here. We've discussed TCP and UDP, the two main transport layer protocols, and how they differ in terms of reliability versus speed. We've also looked at a variety of application layer protocols like HTTP, FTP, SMTP, DNS, and a few more. Each of these protocols plays a specific role in networking, and understanding their functionality helps you better troubleshoot issues, optimize performance, and secure your network. All right, let's quickly recap. TCP is all about reliable data transfer, making sure data arrives intact and in order. UDP prioritizes speed over reliability, making it perfect for real-time applications like gaming and streaming. We also touched on other essential protocols like HTTP for web browsing, FTP and SFTP for file transfers, SMTP for email, DNS for domain name resolution, DHCP for that automatic IP assignment, ICMP for error reporting, and SSH for secure remote access. In the next video, we'll be discussing network topologies and how the physical and logical arrangements of a network can affect its performance, reliability, and scalability. Make sure to subscribe so you don't miss it. Thank you all for watching. I really do mean that. Don't forget to like, comment, and subscribe, and I'll see you all in the next video.